This is the example for time reversal. If we have xn equal to u minus n, so the original one is un. For un, the z transform of this signal is equal to z over z minus 1, where the ROC is z larger than 1. For time reversal or flipping signal u minus n, the z transform of this function is equal to 1 over 1 minus z. In this case, the ROC is z less than 1. The next one is frequency scaling, where you have this function a with the power of n multiplied with xn. So in z transform, we have x z divided by a. So for this one, we have, let's say we have ak, okay, so we multiply with the general equation of z transform. So we rearrange this part, okay, we rearrange this part of ak, so it is 1 over a, so the power of this function become minus k. Same goes to this one, so we can combine into z over a with the power of minus k. So therefore, we have the general equation of frequency scaling is x z over a based on this equation. For example, if we have rk, the scaling of xk, where xk is uk, so for uk, the z transform is z over z minus 1. Since we have since we have scaling of rk is actually equal to this one, so we have xz over r is equal to this function, but we divide by r based on this one, so z over r divided by z over r minus 1, and if we rearrange this equation, it became z divided by z minus r. The next one is multiplication by k. Multiplication by k in the k domain is actually equal to differentiation with respect to z in the z domain. For example, you are given k xk. In this case, xk is equal to uk. For uk, the z transform is equal to z divided by z minus 1, and then based on this equation of multiplication by k, so we multiply this exact equation with negative z and we differentiate xz. So based on differentiation theorem, we have this one for the solution of this part, which after rearrange we have z divided by z minus 1 squared. For example, for this one, we can conclude that if we have signal kxk, or in this case kuk, xk is equal to uk, so the z transform is equal to this one, z over z minus 1 squared. The next one, if we have kxk, where xk now is equal to a with the power of kuk. So we know that for this function, the z transform is z divided by z minus a. So based on this properties equation of multiplication by k, we use this exact value, we differentiate and multiply with negative z. So we have this one after differentiation. So we can conclude that if we have this function kak multiply with uk, k is this one, the signal xk is akuk, so we have the z transform is az divided by z minus a squared.